All right, let's talk about the exam that's on Monday. Again, the classroom assignments are the same as before. So if you went to if whatever classroom you went to for the first two exams, you'll be going to the same classroom again for Monday's class. It'll be during regular class time, so we'll be there at 2:30. We'll start the exam at 2:30, and then you'll have the whole hour and 15 class period to complete the exam. Now, the exam covers chapters 8 and 9. As far as the layout of the exam, there is one question that has four parts, asking you to find perimeter and area of four different figures. So four parts where you have to find the perimeter and area of the four different figures given. Now, uh, these can be compound shapes. They're not just going to be like a triangle. It'll be some of them might be simple shapes like trapezoids or squares or rectangles, but generally you should expect things like if you look at the review, there's compound shapes where you have shapes that can be broken up into smaller shapes, and you have to decide how you want to break apart a shape to find the perimeter and area of the whole shape. Uh, Next, we have another question, which again has four parts, where you have to find surface area and volume. Um, as far as I know, there's no compound shapes for the surface area and volume section. So make sure you know how to find the surface area and volume of a rectangular prism, a pyramid, a cylinder, a cone, um, a sphere. Make sure you know how to find the surface area and volume of basic shapes given their dimensions. So there's four of those where you have to find surface area and volume of all four. And then there is a one question which has 6 parts, all about graphs. These are the general terminology, I guess just terminology, like the degrees of vertices, the number of edges, the number of loops, the number of parallel edges, just things having to do with terminology of graphs, but also Euler circuit slash trail. So know how to find out whether or not a graph has an Euler circuit or an Euler trail, and then know all of the terminology that has to do with graphs. And then the next question has 3 parts, which deal with with the all of the algorithms that we learned for finding the cheapest Hamiltonian cycle. So we'll call this the 3 parts about the nearest neighbor, algorithm, the repeated nearest neighbor algorithm, and the cheapest edge algorithm. Right, so 3 parts. Make sure you know how to do all of those, or apply all of those algorithms to a given graph that has weighted edges. And then there's one more question on the exam, so there's 5 questions total. This one will have 4 parts. And these are questions. So we've covered everything so far with the perimeter surface area, perimeter area, surface area, volume, and then we talked about Euler circuits and trails, and then all of the algorithms that we just covered. So the last question is more of a critical thinking question, where you need to draw graphs given certain situations, certain characteristics. So one question, 4 parts, drawing graphs. These will be questions. I can give examples on this one. The rest of it you should have examples from the review. Does the review have any questions like this? Let me check. The review does not have any problems like that. So let me give you some examples of what I mean here. Drawing graphs. What does that mean? The question will be something like, draw a graph with 4 vertices that has an Euler circuit. So kind of an open-ended question. All you need to do is satisfy these characteristics. It has to have 4 vertices, and it has to have an Euler circuit. So you could do something like draw a graph that has 4 vertices. The simplest graph you can draw that will have an Euler circuit is just a square, I think. And as long as it's a connected graph and all of the vertices have even degrees, then the graph will have an Euler circuit. Right, so it'll be things like this. Or another example of something that could be a characteristic of a graph would be draw a graph with 5 vertices so that two vertices are two vertices have a degree of 3, and 3 vertices have a degree of 2. So make sure you have 5 vertices total, and 2 of the vertices have to have a degree of 3, and the other 3 vertices have a degree of 2. So to fit these characteristics, you'd have to draw a graph that has 5 vertices. So you might want to start with putting 5 vertices, labeling them, and then add some edges to this graph so that in the end 2 vertices are going to have a degree of 3 and 3 vertices are going to have a degree of 2. Right? So we can start adding some edges. If I add this edge here, that makes this a degree 1 and degree 1. If I add another edge like this one, let's say, now A has a degree of 2, So if I want to make that one of my degree 2 vertices, I don't want to add any more edges to vertex A. So essentially, we want to add edges until we satisfy this characteristic. So we can do something like this maybe. And then if I connect these, I currently have degree 2, degree 2, degree 3, degree 2, and this is a 1. I want to make that 1 into a, what do we have? We want 3 of degree 2, and we want a 3. So if I add another edge somewhere connecting like E and B, for example, does that satisfy the requirement? I have a 2, a 2, and a 2, and then 2 3s. Right? So for example, that one satisfies all of the requirements given to me because I have 2 vertices that are degree 3, that's D and B, and then 3 vertices that have a degree of 2, so A, E, and C. Right, so this would be a good enough answer for something like this. So there are 4 parts, 4 questions where you have to draw graphs based on some kind of given characteristic. It could be about Euler circuits, it could be about the degree of the vertices, it could be Euler trail. It won't necessarily be a Hamiltonian cycle because we didn't really consider whether a graph has a Hamiltonian cycle or not. But it could be about Euler, it could be about degrees of vertices, it could be about the number of edges, it could be about the number of loops that a graph has. So any kind of terminology that I could include in a question like that, you should be able to draw a graph with. So knowing terminology with graphs is important for that last question as well. So that's the makeup of the exam. Are there any questions? Oh, there was a question about fractals. I decided to leave fractals off of this exam, not guaranteeing that it won't appear on the final exam, but as far as this exam is concerned, there will not be a fractal question. Are there any other questions about the exam? Let me leave this here in case you were still writing. The final exam will cover all chapters, yes. Can we use a note card? Yes, you can use a note card just like the previous exams. Make sure it's a 3" by 5" note card. You can use one note card for this exam. And then when it comes to the final, we'll talk about what you can use later. The 3D shapes are, I don't think there's any compound 3D shapes, like I said earlier. There are definitely compound shapes when it comes to perimeter and area, but the surface area and volume questions, the 3-dimensional shapes, are mostly not joint shapes. Like there won't be like an ice cream cone with the ice cream on top type of problem, or like, let me see if I have the review on here. I don't. Let me go to Canvas to get the review real quick. Right on here, you have some compound shapes such as this one, and this one. There won't be any compound shapes, but you should know how to calculate the surface area and volume of the parts of these compound shapes. So if I gave you just this cone that's on the bottom of this shape, if it was just the cone, can you do the surface area and volume? If it's this half sphere, can you do surface area and volume? If I gave you this rectangular prism that's on the bottom here, can you do that? Can you do this pyramid? You should be able to do all of those things. I mean, compound shapes doesn't really take it that much further. It's just if you can do the parts, then you can just add those parts together, right? So I'm not testing whether or not you can add things together, but I will ask you to do a cone or a pyramid or a rectangular prism or a triangular prism or a cylinder or a sphere, something like that, where it's just a simple 3D shape. And then there may be compound shapes such as these ones for the surface area and for perimeter and area of shapes. Any other questions? I might open up the homework assignments on WebAssign from earlier this semester. I would say for now, just focus on getting the homework assignments for chapters 8 and 9 that are due the 3rd of December, which is Sunday before the exam. And then after that, I will definitely open the older homework assignments from chapters 5 and 6 for the first exam, and then chapters 2 and 3 from the second exam. I won't be opening chapters 8 and 9 again because you still have time to finish those until this Sunday. So make sure you get the chapters 8 and 9 homeworks done. And then after this exam on Monday, you can go back on WebAssign and go back to homeworks from the first 2 exams, homework assignments, and improve your grades on those. Okay, and you'll have a week to do, more than a week to do that. I'll make all of those chapter 5, 6, and 2, 3 homework assignments due the day before the final exam. So you can go back and fix your WebAssign grade if it's not where you'd hoped. Last thing I want to mention before I tell you what we're doing today is if you go to Canvas, if you've gone to Canvas in the last couple of days, you'll see that the student opinion questionnaires are open for the semester. It's this link at the very top here. You won't have SOQ response rates. That's because I can see response rates for the SOQs. But if you follow this link here, it'll take you to complete your SOQ. I can't see the SOQs because I'm not signed in as a student here. But make sure you go ahead and complete that for each class that you're taking this semester. It's very helpful for teachers to revamp or change aspects of classes that can be improved. They are anonymous and we don't get to see them until winter break, maybe beginning of next semester. So while I can't see who's completed it and who hasn't completed it, I can definitely see response rates. Why can't I open this? The size of what the So I can see, let's see if it shows. Right. So I can see how many students have completed the SOQs. Right now we're sitting at 7 people out of 109 of you that are enrolled in this class. While I'm not allowed to incentivize you, obviously, to give good reviews because it doesn't even matter. I can incentivize you to get them completed. So if we can get this percent response rate up to above 75%, then you all will get some extra points on the final exam. You have until next Friday to complete these SOQs. So if we can get a 75% response rate, then I will add, let's say, 5 points to your final exam, right? Which is a good chunk of points to get added to the final exam. Am I still accepting late ticket indoors? Yeah, just turn them in. I'll get around to putting the grades in when I find some time. If you've submitted a ticket indoor late and your grade hasn't changed from 0 to whatever yet, just give me some time. I'll go through and update those soon. The SOQs are just like a survey on the structure of the class and what you found worked for the class, what didn't really work for the class, what can be improved. It's kind of like a feedback at the end of the semester that the students are expected to fill out for each of their classes. It's when you go to Canvas, the link should pop up at the top. I'll also send an announcement on our Canvas course with the link. So if you can't find it on your Canvas page, it should pop up at the top as a notification on Canvas when you go on there. We are meeting in the same rooms for the exam and the final, correct? Yes, we are meeting. You will be going to the same classroom for the exam and the final that you have been going to for the in-person exams. Apparently, it's also on the SCUF dashboard, the CSUF dashboard, on your student portal. Yeah, so when you sign into portal, I think they're putting it into more and more places so students see them and fill them out. As far as what we're doing today, you can keep putting questions in the chat. As far as what we're doing today, today is going to be pretty much a review day. So I went over what's going to be on the exam. You have the exam 3 review problems that you should be working through. You also have all of the WebAssign homeworks that are due on Sunday. So treat today as a day to kind of catch up on things and study for the exam. I will put you into breakout rooms just so it's easier for me to answer questions individually so I can come to your groups. If you need any help with any of the problems on the exam review worksheet or WebAssign or anything we did in class in the workbook and in the handouts that we did, feel free to ask questions during the group work today.